We've all been there. Neck deep in a project a couple good steps outside of our comfort zones, hyper-focused on the minutiae and fine details, in a quest to make one of our finest pieces of craftsmanship to date. Only to realize amidst all that careful technique and planning, you forgot to do one simple, tiny, little thing. Scrapping the entire part. I was hoping on this knurling tool build that would happen at most once. But like all things, good craftsmanship comes with a lot of lessons. Last time, I finished the first half of this knurling tool build, which was the knurling arm assembly. It required a ton of unique parts to be made, and well, there were a few bumps along the way. Despite that though, this part of the assembly turned out great. In order for this to become a functional tool though, I need to finish the feed pressure assembly, which requires a whole bunch more totally unique parts. So I'd better get to work. First I'll tackle the guide plates. These sort of sandwich all the parts of the feed pressure assembly onto the arms. They include some pivot holes, slots, and of course some rounds. As was the problem in my last video though, the material supplied is right at the final dimensions, meaning I have to undersize everything if I want a nice finish, which, surprise surprise, I do. But I seem to have overlooked this fact when milling the side plate rabbets, as the opening is already bigger than the stock. I'm gonna have to start with some thicker material from my personal stash, and considering this steel is likely older than I am, I'll need to clean it up a bit before I can cut it down to the length I need. I'll then sandwich these two plates in the mill vise and take them down to the correct width by milling both edges. That takes care of one dimension, now to mill these down to thickness. Being that this is cold rolled steel, I'm expecting it to have some residual internal stress, so it's very likely that as soon as I start to mill these faces, the bars are going to bow. To counteract this effect, I'm going to attempt to mill equal amounts from both sides of the bars. And furthermore, I'll do so incrementally, taking alternating 10th passes on each side. This should keep the bowing between the passes at a minimum compared to milling all one side and then all the other. I'll continue this process and start taking lighter and lighter passes until the bars are a perfect fit on the assembly. And my approach for keeping the steel flat seems to have worked perfectly. Next are the pivot holes in each end, which I'll drill at the same time through both bars. In hindsight though, I should have been a bit more cautious with this setup. Even though I milled these two pieces to the same width, the minute flexure of the vise as it's tightened can actually allow the top part to be a bit looser than the bottom. But being that my drilling and reaming operations are only exerting downward force, I got a bit lucky and nothing moved mid-process. Next I'll work on the slots, which I'll have to mill individually. And because I haven't milled the ends of the bars, I'll use a pin mounted in the chuck to pick up the bar location once it's remounted in the vise. The final slot width is right at 1/4 inch. So to make sure I can hold a good tolerance on that dimension, I'll use a slightly smaller end mill. I'll plunge it into depth on one end and mill down the length of the slot right on centerline. Then mill the perimeter to open it up to the target width. Now I can measure this slot with calipers, but a much more accurate way is to use gauge blocks. The .25 block doesn't quite fit in the slot yet, so I'll have to trial and error smaller block stacks to figure out what the actual width is. Looks like I still have 3 thou to go. So I'll bring the end mill back in and take another 1.5 thou off each side, which opens it up just enough for the .25 block. Repeat that whole thing one more time and both guide plates are looking good. But unfortunately, they're useless. As I was inspecting some of the dimensions, I realized the slots did not come out on centerline with the pivot holes. It's only off by 2.5 thou on each, but when these two plates are facing each other in the assembly, that deviation effectively grows to 5 thou. With the tolerances I'm holding for all the other parts of the assembly, this will guarantee that everything will bind up, making the tool unusable. I was really hoping to make it past the very first part before I saw this box again. Actually, you know what? I have an idea. If I just mill 5 thou off one side of this slot, I can bring it back on centerline. It will be a bit wider than intended, but I can account for this by changing just a single dimension on a single part later in the build. Easy enough. And to think I was about to start over. Now if you're wondering how the error happened in the first place, so was I. Then I remembered one small move I made when setting the part up using that pin method before milling. To get the pin to drop into the hole, I had to move the y-axis 2.5 thou. Sound familiar? I didn't think anything of it at the time, but reflecting back now, it was likely that the pin was not running true on the drill chuck. I guess I'd better use this approach more cautiously next time. Anyway, with that crisis averted, I can move on to the final operation of rounding the ends of the rotary table. But I'll first need a fixture plate to do so. So I'll mill a locating pocket and a piece of aluminum tooling plate, then also drop in a pair of reamed holes matching those in the guide plates. After re-zeroing on the rotary table center, I'll drop in a locating pin and place my fixture and part on that pin. And of course, tram it in square with the dial indicator. Then, after locking everything down, bring the mill in and cut the round over a series of 3 to 4 sweeps. Nice. While I have this plate trammed in, I'll drop the second part in and round this end as well, before repositioning the fixture on the other pivot and repeating the same setups and operations through the final 2 rounds. Alright, I made it through. And though the parts are slightly out of spec, I can make up for that on this next piece. This is the trunnion. It's the piece that slides within the slots of the guide plates, and it's the primary connecting element of the upper knurling arm. It also engages with the feed screw, which is retained with some set screw holes. So there's a lot going on here for such a small part. But I'll just take it one step at a time, and hopefully I'll get through without issue. To start, I'll need a clean and square end to reference, which is a quick job on the lathe before jumping over to the mill. All the features to come are at 90 degrees to one another, so I'll clamp this stock in the square collet block before using the edge finder to set all my references. Now the depth of this hole is important for how things will connect later on, but the dimension provided is from the outer diameter of the part to the corner of the drill. And a much more useful dimension for me is to the tip of the drill. So a quick trig calculation tells me the distance from the tip to the shoulder, and therefore how much to account for. Now I can get a light touch on the part diameter with the tip of the drill, zero the DRO, then let the quill feed do its thing, manually stopping it once at depth. Next are the slot guides, which I'll cut with the small end mill. This is a deep cut for such a small diameter mill, so I'll keep the cuts light and take plenty of spring passes. Once I'm at the correct depth and thickness, I can zero my Z-axis hand wheel, then bring the end mill to the inboard side and start forming the second guide. By stopping at the same 0 point on the hand wheel, it ensures that the tabs will come out the same thickness. To measure the distance to the vertical face though, I'll find a stack of gauge blocks that will fit perfectly in that pocket. That I can then measure with the depth micrometer. The idea being that the width of the full round section matches the thickness of the knurling arms. With side 1 complete, I can drop a vise stop against the collet block and flip the block 180 degrees using that stop as a locating reference. It's usually best to put the vise stop in before the initial setup, but I just got a little bit ahead of myself on this one. While finishing the features on this side, I made sure to verify my dimensions were identical to the first. Alright, let's see how that fits on the plate slots. Very smooth. Oh, wait a minute. You idiot. I imagine some of you have been yelling at your screen for a couple minutes now, but I milled these guide tabs in the wrong direction. They should be 90 degrees to how they are, so that the hole I drilled lines up with the pivot hole on top. Wonderful. I was able to save the parts earlier, but I don't think there's any way around this one. There you go, boss. You've claimed your first victim. This time around, I have no option but to use some larger brass stock I had on hand. So I'll turn this down to the correct diameter, and then drill the hole for the feed screw. This time, remembering the all-important step of actually rotating the collet block before milling the slot guides. Luckily, the second time through is always faster than the first. Now to pick up where I left off, I need to stand this block up in the vise. And to find the center axis of the part, I'll use the coaxial indicator riding on the outside diameter. I can't exactly get a clean read around the whole circumference, but if I can get a consistent reading around most of it, I can be reasonably certain I'm on center. But just to be sure though, I'll double check with the edge finder. Yep, that's bang on. From here I can drill the hole for the pair of set screws through what will be both sides of the part. Then of course tap both sides as well. Alright, now this part is ready for the final operation. Oh no, not again. Other than some nicks and dents from where this part was a momentary projectile, the hole I just drilled and tapped is on the wrong side of the part. And better yet, it mangled up the bottom of the hole. I think I'd better just call it a night because this is getting ridiculous. With things going a lot smoother this morning, I quickly whipped up the third attempt, leaving the final operations of parting off the excess and facing the end to length. Finally, after all that fuss, I made it through the whole part without a mistake. It's amazing what a little bit of sleep can do. I won't dare say the next part will be simpler though. I already jinxed myself once. This is referred to as the nut because, well, that's what it is. But it also has a step pin turned on each side as well as a couple flats. I'll start with the lathe work by first facing the material and also whittling away the end to form the first pin. A slight relief cut on the inside corner also helps give tool radius clearance, which makes for a perfect fit with the guide plate pivot hole. And I might as well shine this up a bit while I'm here. Then it's into the collet block for some milling action. First is to cut the flats. I'll place the end mill on center and get a light touch on the diameter. Then bring the table up the full depth and cut the flat in one pass. With everything still set exactly the same, I can then flip the collet block over and cut the second flat. Then is a quick drill, chamfer, and tapping operation before moving back to the lathe. Oh, and can't forget this side either. The stock isn't much longer than the final part, so I'll just face this down the length, then form the pin on this side as well. Looking good. Let's keep this ball of good fortune rolling. Next is the feed screw. This has threads, obviously, as well as some turn features on one end and a cross hole on the other. I'll start with the threads, but first I have a little prep work to do. The length of this threaded section is fairly long, so I'll center drill the end in preparation for some tailstock support. The material is already right at the thread diameter, so next is to turn a thread runout groove which I can form with the parting blade. I prefer to feed with the compound which is already set at 60 degrees, so all that's left is to set the feed rate to match the 24 TPI pitch I tapped on the nut, coat the shaft in layout fluid, and take a scratch pass. Maybe a deeper scratch pass. Well, this is odd. I don't seem to be getting a consistent cutting depth along the part. The diameter is coming out consistent, so this can only mean one thing. My tailstock must be deflecting the end of the shaft toward the cutter. This isn't surprising at all given how much I have to adjust the tailstock depending on where it is on the lathe bed. Long story. Anyway, it's a good thing I took that scratch pass. A dial indicator confirms my suspicions. You can see that deflection when I extend and retract the live center. And sweeping along the part shows the deflection as well. Fortunately, I don't necessarily have to break down my setup to make this small adjustment. In fact, the part as it's mounted is a perfect aid for bringing the tailstock in true. Alright, that's much better. With the rod now held straight, I'll start taking cuts, adjusting the compound slide between each. These cuts get lighter and lighter until eventually the threads are a perfect fit for the brass nut. I did just realize one little goof up I made though. I forgot to account for some extra length to cut off the center drilled end. But considering this will be a hidden feature and also won't affect performance, I'm going to let practicality take precedence here and let it slide. Plus, I don't want to start over on yet another part. Now to work on the other end that engages with the brass trunnion. To cut the 60-degree set screw groove, I'll use the threading tool. The critical dimension given is from the inboard shoulder, so I'll center the tip of the cutter on this edge with my handy-dandy micrometer, then get a touch on the diameter at my starting point, and feed the compound slide in at a matching 60-degree angle, so I'm only cutting on one side of the insert. Once at depth, I'll sweep the cutter to make the groove. Next is to cut the taper on the tip, which needs to match the 118-degree drill bit I used in the trunnion. So I'll adjust the compound angle just slightly to 59 degrees and start cutting the taper on the end. Before I get too far though, I need to check that this taper truly does match the taper in the trunnion hole. It's important that these two mate properly to reduce wear, as this joint will see a lot of load during use. So I'll coat the tip in layout fluid, and once dry, insert the trunnion, rotate it a bit, and observe the contact patches. Looks like the outer edge is the only thing touching. So I'll adjust the compound a bit steeper, before taking another cut and retesting the fit. That's more like it. You can see where the blue has been rubbed off more evenly across the face, meaning the clamping load will be more evenly distributed. With the angle dialed in, I can continue taking passes until the set screw groove lines up with the set screw holes in the trunnion. Then this part is complete. I also went ahead and turned up a simple pin I'll need for assembly as well, which leaves just one quick piece to make before I can use this tool for the first time. That being the tool holder clamping block that mounts on the back. It will end up getting mangled by the clamping screws when it's mounted on the lathe, but I can't resist first milling all the faces to match the appearance of the rest of the tool's surfaces. So after face milling the sides and side milling the ends, I can drop the through holes for the screws in here, counterbore those holes to hide the screw heads, and of course chamfer everything. Now this isn't the last piece I'll be making, but it was the last piece I needed in order to make the last pieces I will need. I'll explain in a minute. But first some assembly. The feed screw inserts into the trunnion and is held in place with some set screws. Next, the nut can be threaded onto the feed screw. This assembly gets dropped down onto the first guide plate like so, and I can slide the trunnion into the top knurler arm. A pin goes through the bottom knurler arm and the guide plate underneath, then the second guide plate is placed on top. And it all gets sandwiched and held in place by the outer side plate and some flathead screws. After attaching the cam lever and lastly the mounting block, this thing is ready for use. And the trial run is actually going to be making the last couple parts, which are the knurled knobs for the cam lever and lead screw. First, the cam lever. I'll start by facing and turning down the stock's diameter. Now this diameter is kind of important for getting the knurling to come out right. In essence, the circumference needs to be a multiple of the knurling wheel pitch so the grooves line up as they go around each time. But there's a little more to it than that. As the teeth press into the material, the diameter actually grows from the deformation, and the teeth simultaneously go deeper. A lot to keep track of, but fortunately, like most things these days, there are online calculators like this to help speed up the math. I can plug in all the knurling wheel parameters, then the diameter I want the final knurl to be. This will tell me the nearest actual final diameters I could achieve and still have the pitches line up. So I'll pick one of those and re-enter this back over here, and this gives me the starting diameter I need to turn my material to. Back on the lathe, I'll hone in on that diameter until I'm spot on, then it's time to actually test this thing out. I'll get this set up in a tool holder, and then center it up on the stock and close the wheels with the feed screw until they're just touching. Then, with the material spinning, I'll pull the cam lever to close the wheels just a bit more, to start the knurling and feed across the part. Well, it made some knurls, but not how I expected. Looks like I might have gone a little too deep, and the leading edge actually cut the metal rather than deforming it. And even stranger, the knurl seems to have twisted around the stock. I wonder if... Yep, it might help if I actually locked down the tool post. It must have been the new tool jitters. Let's try this again. This time, double checking that everything is secure, and not engaging the cam lever quite so much. Much better. Nice straight knurls, and no cutting. The rest of this knob consists of a hole in the end, and a decorative taper that I can form with the compound slide. With that parted off, I still have a little finishing work to do on the other end, but first I'll attach it to the cam lever. A soft copper mallet ensures I don't deform the threaded end while tapping this in place. Then back on the lathe, I can clamp on the cam lever stem and clean up the end of the knob, which of course includes a chamfer. Alright, one knob down and one to go. After facing and turning down the diameter of the stock, I'll drop another nice chamfer on here, then drill and tap the hole in the end. This hole is blind, so the tap I'm using is a bottoming type so that I can get the threads as near to the bottom as possible. With the first side taken care of, I'll flip this in the chuck and start work on the other end. First turning down the diameter to form the smaller pin, then bringing in the new toy once again. Looks like I went a little too deep again, but other than that, it looks pretty good. I'll turn a decorative area on the inboard side, and then you know what goes here. Now this piece is just about finished. It threads onto the feed screw, but they both get cross-drilled to accept the crossbar. So I'll get this all taken apart one last time and set up in the mill. I have the feed screw threaded in as far as it goes, so by drilling and reaming through both, I guarantee alignment. And it's a perfect light friction fit for the crossbar. This just leaves one last and final operation of the crossbar itself, which is a quick part to length and a ball radius filed on each end. Nice. Now that's literally all the parts complete. Other than now having a new functional tool, this is probably the most rewarding part of this build. That being putting all the pieces together for the final time. Everything just goes together so nicely. And with the tolerances I managed to hold, everything moves freely. But also doesn't rattle all around like the proverbial box of marbles. On top of all that, it's just a real treat for the eyes to see all the different materials come together and complement one another, and in such an elegant and thoughtful design. You know what, I couldn't think of a better way to send off this build than with a few more test knurls. Yeah, that's not going to get old. I may find myself knurling just about everything with a tool this nice. And hopefully, those future projects will have a few less mistakes. As always, thanks for watching, and see you next time.